In this video, I'll be working through the question you see on the screen from the Mechanics paper 4.2 from the Cambridge A-level exams from 2023. I'll be doing this on the board, hopefully just like you're used to your teacher doing in a classroom. If you want any other questions from this paper, you should be able to find a link to the playlist in the description below. And if you find any of my videos useful, I'd greatly appreciate if you subscribe, or if you think any of your friends might find it useful, please go ahead and share it. In question 6, they tell us about a particle P starting at rest, so it's stopped at start, and it moves in a straight line. So let's just put a little line up. First, starting point's at O, the origin. And it tells us the velocity of P, V, is given by a formula. And that formula is V, or phi t. Oh yeah, it doesn't have a T, but I'll put a T in. Phi t is equal to Bt plus C, T to the power of 3 over 2. Where B and C are just some constants, some numbers we don't know yet. And it tells us P has a velocity of 8 when t equals 4. So after 4 seconds, the velocity of this particle is going 8, positive 8. And after 9 seconds, the velocity is 13. Let's write that here somewhere. T equals 4 and velocity is 8, phi equals 8. T equals 9 and velocity equals 13.5. Okay, for part A then, it simply asks us to show that B is equal to 3 and C is equal to minus 0.5. Another way to say that is just find B and C. So that, because a lot of students get confused by how do I show this? And they tend to just put it in here. Actually, that sort of works, I suppose. And you could just put those numbers into this and then put 4 in and see if we get 8. Put the numbers they gave into this, then put 9 in and see if we get 13.5. Actually, yeah, that would work. But the way I like to usually do it is I just try and find B and C, and then I hope it matches what they said. So how would I find B and C? So, somewhat similar. I'd use these numbers here. Instead of V, I would put 8. Instead of T, I would put 4. And we'll just do that twice, or we'll clean this one up first. And no, let's do the other one next. We'll do 13.5 is equal to B times 9. I'm just filling in these two numbers in with instead of V and instead of T. Plus C, 9 to the power of 3 over 2. We have two equations. Sorry. We have two equations and two unknowns. This is just a simultaneous equation. We can clean it up a good bit though. This would be 8 is equal to 4b. 4 to the power of 3 over 2. We can check this, but it's square. The over 2 part is just the square root. Square root of 2 is 4 is 2. 2 to the power of 3 is 8. So we get 8c. And somewhat similar here for the square root of 9 is 3. 3 to the power of 3 is 27. 27c. So we have these two equations here. This one and this one. Simultaneous equations. You should all be well used to doing this. It's not the easiest one though, but we just need to match up two of the numbers. You can match up the C's or the B's. I just chose to do the B's. I'll choose to multiply this guy by 9 and I'll multiply this guy by 4. Just so the B, I'll get 36 in both of these spots. So multiply everything here by 9, I would get 72 equals 36b plus 72c. I multiply everything here by 4, I would get, let's see, 40, 52, 54 is equal to 36b plus times 4 is 108. 108c. Let's take these away from each other and we will get, let's get the c is positive. So this line minus this line will get 28 plus another 8 is 36. 36c on this side equals this minus this is minus 18. C is equal minus 18 over 36. C is equal to minus 0.5, which is what they wanted us to show. And then just fill that into any equation you want. I'll just fill into this one here. 8 is equal to 4b plus 8 times minus a half is minus 4. That's 4b is equal to 12. That's b is equal to 3, which is again what they wanted. So that's how I would have done that. But like I said, I guess from the very start you could have just filled in the numbers they gave you and check if this works and check if this works, and that they would have accepted that as well. There's only 1 mark for that, but then this is just simple simultaneous equations, so I expect you to be able to do either way, although I expect most students to do it this slightly longer way. Okay, let me clean some of this off and we'll do part B. Okay, on to part B. First of all, I've replaced the velocity formula they gave us with, I've taken the b's out and put 3 in, I've taken the c out and put minus a half in. That's what they wanted us, that's why they gave us the answer in part A, so we could continue on even if we didn't know how to do part A. Okay, for part B, they want us to find the acceleration. We have velocity, how do we get acceleration? It's not those motion formulas, they only work in certain situations. They do not work for a complicated function like this. We differentiate. Velocity goes to acceleration by differentiation. So differentiate this, we get 3t turns into 3. Differentiate this, we'll have a minus, we'll have a half, multiplied by 3 over 2, t to the power of 1, take 1 away from 3 over 2, and we get 1 over 2. And let's clean that up. We get 3 minus 3/4 t to the power of a half, or square root of t if you'd rather. So that's a formula for acceleration everywhere. But they only asked us when t equals 1. So let's just find a when t equals 1, and that's 3 minus 3 over 4, 1 to the power of a half. And that's 3 minus 3 over 4, and that's, let's see, that's 12 over 4 minus 3 over 4 is equal 9 over 4. And that's okay as your answer, but we tend to, in mechanics, we tend to put decimals in more. That's 2.25. And, sorry, this wasn't okay because we still needed the units. So acceleration units is meters per seconds squared. Okay, that's your full marks for part B. Okay, on to part C. The question says, find the positive value of t when p is at instantaneous rest, and find the distance of p from the origin at that instant. Okay, at this point it might be useful to go back a little bit, to use this picture up here and explain what's happening. And we can tell what's happening by the velocity formula here. So it starts at rest, and then we know what happens when t equals 4. They gave us a velocity of 8. So it's speeding away here. And at t equals, I think it was 9, the velocity was 13.5. So it's getting faster, it's going faster and faster. But because there's a minus here, and t to the power of 1.5 is bigger than t, when t becomes bigger, this guy is going to dominate. Even though he's a half and this is 3 times, this guy is going to dominate when t becomes like 1,000, 1,000,000, 1,000,000,000. And that means if he dominates, the minus is going to dominate, and velocity is start going to go that way. Just from this image, I know all this. So even though we're speeding this way, it seems to be accelerating this way. At some time, it's speeding up. At some time, it must slow down. I know it must slow down because I know it must stop, because I know it must start going that way. And that's roughly what happens. I get that in this. It speeds up, slows down, stops, speeds up, and never stops speeding, goes flying past the origin again. And that's that'll be for part D then. We need to know it goes back past the origin. Okay, that's something I noticed just after doing part A. Just when I see this equation, I thought what's actually happening in this. You don't necessarily need to know that, but it does usually help. So for part C, that's what I'm trying to find a point where it stops over here. It's going to slow down. It's going to come to instantaneous rest. Again, you don't need to know all that. All you need to know is when you see the word instantaneous rest, you should be thinking velocity equals 0. Phi t equals 0. But you also know what velocity is. It's equal to 3t minus a half t to the power of 3 over 2. Really, that's all you need. Well, not all, but it's useful, I think, to have an image of what's going on. But we can do this with maths. We have an equation here with one unknown. We can go ahead and try and solve this. It's not very easy, but t goes into both of these. It goes into this 3 times, and it goes into this minus a half t to the power of a half times. Two numbers multiply to get 0. We know one of these must equal 0. Either t equals 0 or 3 minus a half t to the power of a half equals 0. Now here's where they were a little tricky. They asked for positive value of t. Some students would probably say, there we go. That's positive. There's no minus. That's where it's just a little trick that it's probably best to remember. 0 is not positive. It's not negative, it's neither. It's not positive or negative. So if they ask for positive, you have to throw away the 0 answer. A little line through, just tell the examiner you're throwing it away. So we're going to use this one here. Let's clean that up. 3 equals a half t over t to the power of a half. Multiply across by 2, we get 6 equals t to the power of a half. Square both sides, we get 36 equals t. And that's the answer. That's a positive answer for t. So after 36 seconds, this particle has slowed down to rest, and we're about, well, I'm telling you, we're about to start going that way, and part D also tells us we're about to come flying back through the origin. Okay, let me clean some of this off. I'll just leave the speed and the acceleration, and we'll do part D. Now, I thought part C went a little quick, and it did, because we're not finished yet. They didn't ask for the time it took to get to instantaneous rest. It asked for the distance from O. So it's over here somewhere. We'll put it in some point here. What's the distance to this point? We know the time. We know t. Let's put it here. T equals 36. That's what I found out before. We needed to do that, but we still need to find out the distance. To get the distance, we could just work out the displacement. Usually I put it here like displacement, speed, acceleration. I'll put it down here though. The displacement at a certain time. And we can get the displacement by, well, if we differentiate the displacement, we get the speed. If we differentiate the speed, we get the acceleration. That's why it should really be up here. To get back from velocity to displacement, it's just the integral of phi t dt. So we can go ahead and do that. We can go ahead and integrate this guy. This is going to be the integral of 3t minus a half t to the power of 3 over 2. Let's say dt. We can also integrate between 0 and 36 if you want. Time 0 and time 36. That'll get this distance. We don't need to do that. We can just get a constant, and because we know where we were at time 0, we know the constant is 0. Like the distance from the 0 point, we decide is 0. So you could put 0, 36, but you don't have to. We just you need to know that the constant is then 0. Okay, what's the integral of this? This becomes 3 times t squared divided by 2. The 2 comes down. The next one becomes minus a half t to the 5 over 2, and divide by 5 over 2, or multiply by 2 over 5, plus a constant, and that constant will go to 0. Just because we know about the origin, we know the distance from the origin. Or we make it up really. Okay, so let's clean this guy up. S is equal to 3 over 2 t squared minus 1 over 5 t to the 5 over 2. And we know what time we're interested in, S36. And that will be equal to 3 over 2, 36 squared minus 1 over 5 t, 36 to the power of 5 over 2. And you just put that into a calculator, which I believe I have here somewhere. No, that's not it. Oh, there it is. 388.8 will be the distance from, meters. Always remember putting in your meters. Before we go on from part C, just a point on the mistake I made by thinking I was finished when I got 36. There was 5 marks for that question. So that should have been a clue. I did not do 5 marks worth of work until I did a bit of integration here. So there's often a little clue like that when you make a mistake. Okay, on to part D, and I think I have room here. In part D, they want the speed of P the instant it returns to the origin. So like I said, this is speeding up and then slowing down, stopping, and then speeding up, going this way. We just there's a few ways to do this. We just need to know when does it return to the origin, and we know the distance from the origin is 0. The origin is the origin; it's 0, and we have a formula for distance. This one up here is the cleanest one. So let me just. I shouldn't need too much room here. T equals 0. Which is equal to 3 over 2 t squared minus 1 over 5 t to the 5 over 2. So again, just like in part, I think it was part B, we just need to solve this equation. And it's very similar. Solution 0 is equal. What goes into both of these? T squared does. T squared goes in 3 over 2 times minus 1 over 5. And it leaves t to the power of a half. The answer is either t squared equals 0, which is t equals 0, or 3 over 2 minus a fifth t to the power of a half equals 0. And we can discount this one because t equals 0, we already knew that. It was at rest at t equals 0, started there. They asked it returns to the origin. So this is not the one we're interested in. So we need to solve this one here. Let's see, bring that over the equals. We get 3 over 2 is equal to 1 over 5 t to the power of a half. And multiply across, we get 15 over 2 is equal to t to the half. And that's 7.5. Square both sides, and 7.5 squared, there it is there, 56.25 is equal to t. That's in seconds. They didn't ask for the time it returns to the origin. They asked for the velocity. So the velocity at the time, 56.5. And again, we have a formula for that. That's the advantage of doing these formulas at the start. In fact, at the very start of this question, when I was doing it myself, they gave me velocity. I found B and C. But once I got that, I just wrote down acceleration and displacement. I just do that to every question. They give me displacement. Well, I'm going to differentiate it. Get velocity, get acceleration, even if they don't ask me. It's quite quick to do at the start, and then the rest of the question goes really quickly usually. So anyway, velocity is 3, do I have enough room here? Let's put the equals down here. It's 3 multiplied by 56.25 minus a half, 56.25 to the power of 3 over 2. And again, you can put all that into the calculator. And do I have the wrong number? Oh no, there it is there. Okay. Put all that into a calculator and you will get minus 42.1875, rounds up to 0.2. That looks like the answer. But you are going to lose, let's see, 3 marks for this. If you left this as your answer, I think they'd give you only 1 out of 3, which is really unfortunate because that's most of the work. If you leave this as your answer, they'll probably give you 2 out of 3 because this is not the answer they're looking for. They ask you to find the speed. This is velocity because it has a minus. Speed can never have a minus. They simply want you to write 42.2 then as the as the final answer, meters per second. Okay, that's a mean way to finish. If anybody lost a mark for just that minus there, I'm sorry. But that's what happens in exams sometimes. They're trying to trick you. They're trying to get the last little bit of knowledge out of you. Okay, I hope that answered this entire question. If you have any follow-ups, any mistakes I made, anything you weren't sure on, please put them in the comments below. I'll do my best to get back to you. I'll do my best to answer better than I've done here. Thanks for watching and have a great day.